Solve for x in each of the following. Now I'm going to show you that unless we say you have to use indices, you can also use logs, unless we say just use indices. What we're doing now is, this is called indicial equations, which means we are working with indices. Now, something that I need to understand is I need to get my bases the same. I have one term on each side, so if I can write 32 as the base of 2, I can say 2 to the power x equals 32 is 2 to the power 5. Once I know that 2 to the power something equals 2 to the power 5, then those two things there must equal the same, so I can say therefore x must equal 5. And that's my answer. Was there another way? You bet ya. What I can do is, if I have 2 to the power x equals 32, what I can do is I can take log on both sides. I can say log 2 x equals log 32. I can move the x to the front. I get x log 2. And what I'm going to do is I'm going to write log 32 as log 2 to the base, or to the power 5. I'm then going to move the 5 to the front, so I'm going to say x log 2 equals the 5 goes to the front, 5 log 2. And what I'm going to do is I'm going to divide both sides with log 2, which means x equals 5 log 2 divided by log 2. These are exactly the same, that equals 1. So my answer is 5. Any one of those two will be fine, as long as you understand both of them. Let's look at the second one, 5 to the power minus x. Usually, these ones are pretty straightforward, and all I have to do is get the bases the same. 5 to the power minus x equals 125. Now I can say that is 5 to the power negative x equals 125. I can write as 5 cubed. The moment that these are the same, I can say therefore negative x equals 3. Multiply both sides with negative 1, so x equals negative 3. Exponents, I could do exactly the same as what I've done here, take log both sides. 3 to the power x, so 3 to the power x equals 1 over 27. I can rewrite this as 3 to the power x, which equals 1 over 3 cubed. I can now write this 3 to the power x equals, this goes above the line, it becomes 3 to the power negative 3. The moment that these are the same, x must equal negative 3. Then those two must be the same. Indeed, it's important that I only have one factor on both sides. So what I'm going to do is I'm first going to divide by 2 on both sides. Okay, so what I'm going to do is I'm going to divide by 2. I'm going to divide by 2. That will give me 3 to the power x, which equals 81. See if I can get the bases the same. 3 to the power x equals 81 is 3 to the power 4. Bases are the same, therefore x equals 4. If you wanted to do this with log, I'm going to show you. If I have 2 times 3 to the power x equals 162, and I take log on both sides, then, there needs to be a log there. So that is log of 162. I have to split this up, and this log means it's the log of 2 plus the log of 3 to the power x, which equals log of 162. I can subtract log 2 on both sides, which means this x can go to the front, x log 3 equals, that log 2 goes to the other side, becomes log 162, take away log 2. Okay, that equals now x log 3, which equals, this is the same as the log of 162 divided by 2 according to my log laws. I'm just going to carry on here because I can. It's going to give us x log 3 equal, and that will give us a log of 81. X log 3 equals, log 81 is the same as the log of 3 to the power 4. The 4 can go to the front, so x log 3 equals 4 log 3. I now divide both sides with log 3, and if I divide by log 3 on both sides, x equals 4, exactly the same as there. Now this might seem unnecessary, but soon you'll see why I'm showing you that. Okay, if it's a little bit harder, last question, this is E. 2 to the power x minus 1 equals 16. I can say 2 equals x minus 1, which equals 16, which is 2 to the power 4. So I just want to get the bases the same. Once the bases are the same, then the exponents must be the same. So x minus 1 must equal 4. I add 1 both sides, or I say the 1 goes to the other side, becomes plus. So x equals 4 plus 1, so x equals 5. Just maybe check your answer every now and again. If I put 5 in there, 5 take 1 is 4, 2 to the power 4 is 16, bada bing, bada bang.